grade 11 pre-cal, lesson 47, radical equations. So now what we're going to do is we're going to take the radicals and we're going to make equations out of them. Do you remember that? That just makes it equal to something. So when you're dealing with radicals, you always have to talk about restrictions. Now, if you look at this, we have root of 2x minus 1 right here. Well, there's a restriction on that, right? Because you have to remember that radical can't be a negative. Because if it's a negative, you can't take the square root of it, or cube root. Well, you can take cube roots of negative. You can't take the square root of it. So what we can do is we can set a restriction. So to do the restriction, all we do is take what's underneath the radical symbol and set it greater than or equal to 0. It can be equal to 0, has to be greater than, and it has to be positive. So then we can do the math and we can go through this. X is greater than or equal to a half. The reason we do that is because if you get a restriction and you end up with an answer that's equal to the restriction, it can't happen. Okay, so look at this first example here, and we'll just do it. To do it, it's the same procedure in solving any equations. You got to get the variables by itself. So look at this one here. So we have 5 plus root of 2x minus 1 equals 12. Well, the first thing I would do is get rid of the 5. Move the 5 to the other side. To do that, you would subtract 5 from both sides. Okay, so we end up with root of 2x minus 1 equals 7. Now, when we talk about solving equations, you always want to do the opposite of what it was, right? So if it was positive, you would subtract it, right? If it was multiplication, you divide it. Well, what's the opposite of square rooting something? Well, square it. Okay, so if we square root both sides, remember you got to do it to both sides. If you take the square root of, if you square the square root of 2x minus 1, you end up with 2x minus 1. 7 squared is 49. Okay, well now, look, we've gotten rid of the radical symbol. Now we can solve this. We have negative 1, so move the 1 to the other side or add 1 to both sides. We end up with 2x equals 50. Then we divide both sides by 2. We end up with x equals 25. Now, is that okay with our restriction? Yeah, x has to be greater than or equal to a half. And this one falls into that category, so it could be an answer. But should you always check it? Yeah. And to check it, all you do is plug it back into the original equation and make sure the left side equals the right side. So we plug in 25. We do all the math. Yeah, left side 12, right side 12. So both sides equal each other, so we know this is one of the answers. Okay, go to the second page. Let's do another one. So state the restrictions on this one, and then solve. So the restrictions have to do with what's underneath the radical symbol. So that's 5 minus n. So set it equal to greater than or equal to 0 because we want it positive. We move everything around, right? 5 is greater than or equal to n, or n is less than or equal to 5. That's our restriction. So now let's solve it. Well, what do you want to do? It's really kind of hard to do this one. I don't really want to square the negative root of 5 minus n. So what I'm going to do is I'm going to put the negative 5 minus n onto the right-hand side, which makes it a positive. I'm going to move the negative 7 over to the left-hand side, which makes it a positive. Okay, so then I end up with n plus 7 equals root of 5 minus n. Right? It doesn't matter which way you do this. Now, it's a square root, so what do? We square both sides. Now, careful on this one. N plus 7 is 2 binomials. And if you need to, write it out as 2 binomials because you're going to have to FOIL it. The most common mistake is to take something like this and put n squared plus 49. Well, no, that's not the answer. There is a center term in this case. So it's n squared plus 14n plus 49 equals 5 minus n. Now, to do this, you set it all equal to 0. So we're going to bring the n over to this side and the 5 over to this side. And if you look, we have a trinomial. Now, how do you do this? Well, you try to see if it factors. Okay, so we take this, and this one actually works nice. There's a positive in front of the 44, means both sides are the signs are the same. Factors of 44 when added together give you 15 or 4 and 11. Yeah, and we do the math. We find out n is negative 4 and n is negative 11. Now, if you couldn't factor that, could you use the quadratic formula? And yeah, and that's what we do over on the right-hand side here. We use the quadratic formula, plug in everything. Do we get the same answers? Hey, look, n minus 4, or sorry, n equals negative 4, n equals negative 4, n equals negative 11, n equals negative 11. You get the same answers. Now, should we check to see if our work is correct? Now, what's first off, what is our, yeah, n has to be less than or equal to 5. Yeah, they're both negative, so that works. That states that restriction. But let's check them. So what we're going to do, we're going to plug them both back into the originals. So we plug in n equals negative 4. We plug it into the original. We see the left side equals the right side. Negative 7 equals negative 7 when we do all the math. Now, look at this one here. N equals negative 11. We plug it in. We find out, we do all the math. Negative 15 equals negative 7. No, that's not right. That doesn't equal. So we put in non-equal to. So what that's known as is an extraneous root. We needed that number, the n equals negative 11, to be able to do all this math. But when we plug it back into the original question, we find out it doesn't satisfy it. So there's only one answer in this case. And the answer in this case is n equals negative 4. n equals negative 11 is known as an extraneous root. Okay, flip the third page, we'll do another one. So this one, they're getting more complex. Well, there's a couple of options of this. I mean, you could square both sides, but that's kind of, this right-hand side's kind of gross to be working with. So what we're going to do is I'm going to move the 5 over. I'm going to get rid of this positive 5. So to do that, I subtract 5 from both sides. So we end up with 7 minus 5, which is 2 plus root of 3x equals root of 5x plus 4. Okay, I can handle that. So what I'm going to do is I'm going to square both sides. So we square both sides. Well, the right-hand side is really easy because it's root of 5x plus 4, so we end up with 5x plus 4. Now this one, that's two binomials, and you're going to have to do FOIL, right? First, outside, inside, last. So what we do is when we do the FOIL, and write it out as two binomials if you're struggling with that, we end up with 4 plus 4 root of 3x plus 3x. Well, we still have a radical in here. What do we got to do? Well, if you notice, there's two radicals up at the beginning, which means you're going to have to do this squaring process twice. If there was 3 radicals up there, you'd probably have to do it 3 times. So let's combine some like terms. So 4 root of 3x, we're just going to leave by itself. We're going to move the 4 to the other side, subtract 4 from both sides, which is nice because they just cancel out. We're going to move this 3x over to the other side, which is subtract. Oh, yeah, we end up with 4 root of 3x equals 2x. Now, we got to get the radical out of there. So let's square both sides again. So we square both sides. Now, don't forget that 4 has to be squared. So 16 times 3x. And this has to be squared also. So 2x times 2x is 4x squared. Okay. So 16 times 3x is 48x equals 4x squared. Well, how do we solve this? Get it all equal to 0 because we have a square there. So we end up with 4x squared minus 48x. What's common to both of those? Well, we can take a 4x out of both. So 4x squared divided by 4x is just x. Negative 48x divided by 4x is negative 12. And then we just set them both equal to 0. So 4x equals 0. So x equals 0 is one of the answers. X minus 12, set that equal to 0. We end up with 12 equals x. Okay. Do those both work? Well, let's find out. The only way to do this is plug them back into the original. We got to plug x in this one here. X equals 0. We got to plug x equal to 12 into this one. So we plug it in. We see if the left side equals the right side. Yeah, we do all the work. 7 equals 7. Here, we plug in the 12. We do all the work. Yeah, 13 equals 13. Perfect. So in that case, both of those are answers. Okay.